So welcome to this talk about building Android apps with Gradle. In this short 45 minutes, I try to provide you an intro about the current state of the Android Gradle plugin, and have some demos prepared. And at the end, let's see how it fits into the schedule. We will look at the forecast of what we are currently working on or what's expected to be added in the future to the Gradle Android plugin. My name is Rene Groeschke. I'm working for Gradleware since more than 3 years now, doing consulting, but mostly doing I'm focused now on core development and mostly on the Gradle part of what we want to change in order to achieve different things with the Android build team. So, first of all, why we needed the Android build or the Android tooling and new build system? I think it was already 2 years ago when the Google tooling team evaluated different solutions or looked at what's already there. So let's take a look at the old Android builds. So in the former days, we had 2 official build mechanisms provided by the Google guys. One was an Eclipse-based ADT, so the Android Development Toolkit, and there was ARM support, and there was a pretty, but not official, successful Maven plugin for building Android apps, which was really broadly used as far as I can see. But when it comes to customizations, there was more or less nothing in there. There's nothing in ADT, so well you can export in APK or something, but to customize the process of building that APK, there was nothing in it. I don't know if you might be able to hack into the Eclipse extension point, whatever. But if you use ARM, if you use ARM, you have all kinds of options, because you can basically hack the XML in the way you needed it. But as I say here, you need to hack XML. I don't know. I don't do that anymore. I don't like that. And it was really error prone. So, and there was no default conventions, stuff like this. Everything was manually set up. Yeah, with Maven, well, I guess you could customize some stuff, but if you want to make Maven something that you would like to have, but the Maven guys consider it not to be something worth, you need to write a plugin for that, and that's quite a pain. What often people do when they, in general, need to do something special or customize a Maven, they call Antas. That's what I saw in the past. So, all a bit clumsy. So the requirements for the new build system, when the Google guys looked out for new solutions, they had one of the strongest requirements was that they wanted to have one tool for running it from the command line, running it on the CI infrastructure, and also in the IDE. So in the past, the Eclipse ADT and the command line solution, maybe based on ARM or Maven, was completely separated, so it was not a unique tool to use. That's what I wanted to change. Also, one requirement was to have application and library variants, so that you have a distinction between an Android application and the Android library, and support for variants. I'll explain later on what I mean by variants, but in short, a variant, for example, is you have a free version and a paid version. That's 2 different variants of your of the same application. One thing they learned, I guess, from Arthur, what you need those days is a good dependency management. So I think that's one of the reasons why the Maven plugin was quite successful. And they want to have a plugin ecosystem which can be leveraged so that you have an Android-based build system where third-party contributors can add on their plugins on it. Later on I have some examples for that. So if you look at those requirements and you're quite familiar with Gradle, you see that it was quite a good fit. So why they have chosen Gradle? So short abstract, I guess everybody knows basically Gradle. Not so much, okay. Gradle is written in a domain-specific language, or all build files are written in a domain-specific language based on Ruby. That's why I'm here, I guess, to express the build logic. It's very flexible for customization, so it comes with conventions like the Maven, but it's really easy to customize it or adapt it to your needs. And I don't want to do any more Maven blaming. It's
Why not?
And it's well integrated in the CI ecosystem. So we ship with ARN support. So if you write a build script in Gradle, you can basically call any ARN task out of it. We have support for dealing with Maven and agile repositories, so you can resolve and publish your dependencies, generating forms and all that crap. And yeah, the integration with the CI servers is quite good. Basically it's a command line tool, so there's nothing fancy to it, so it can be integrated to every CI server. But there are a couple of nice plugins, for example, for TeamCity or Jenkins. And another big plus for Gradle was there is a tooling API, which is part of the Gradle open source distribution. The tooling API is a library we provide to programmatically trigger builds or query action against builds. So you can ask a build script for get information about which sources are used, which dependencies are used, all that kind of stuff. And that was later on when we look at the Android IDE at the moment, we see how that integrates. So for those of you who haven't seen Gradle yet, I assume it's not that many. So that's a Gradle in a nutshell. It's a build.gradle file based on the Groovy DSL, what I mentioned. Gradle ships with several plugins. I guess the most popular one is the Java plugin. A plugin brings different kinds of things. One is tasks, so you by just applying the plugin, you get tasks for compiling your production code, your test code, to run your test code, to package it as a jar. But it also comes or ships with conventions. So, for example, the Java plugin applies the same conventions like the Maven default plugin does. So you have source main Java for production code or source test Java for your test code. You can declare, it's quite easy to declare custom tasks if you like, so you can do that directly in your build script, or you can hide it in a plugin. A plugin, has anybody ever written a plugin in Maven? Yeah, so in Gradle it's just one, all you need to care is you need to implement one method, which is apply plugin. Pretty simple to do. Don't go into details here. And you need to remember that everything in a build script is Groovy, so you can use the whole Groovy features like reading files. That's one of the reasons why Greach has chosen to use Groovy. So if I want to set a version, I can extract that into a specific file, and it's a one-liner with Groovy to read that. So pretty easy. So that was plain Gradle. So now we enter the Android world. The Android build system is basically a plugin for Gradle. That's more or less the simplest or the shortest build script you can have for your plugin. you declare a dependency on the plugin. You say that's a third-party plugin. We will resolve that using we have a plugin portal which is triggered automatically, and we resolve a specific version. In that case, 1.1.plus. And this plugin brings in a whole new section to your build, to that Android closure thing here, and everything you do with your Android stuff or Android specific things you do in that Android block, basically. So there are two things you need to set. So required, one is a compile SDK version, and one is a build tools version. That's basically all you need. So if you have that in place, you can run Gradle check assemble to run all your tests. Later on we see, well, I show you how that looks like, and assemble builds all the APKs. I say APKs because in Gradle you usually, or with that new build system, you usually build more than one APK. I guess I think in the former build system that wasn't possible. So if you needed to build different APKs, you needed to deal with different projects, and there was no support for that. So first step of customization is there's a default config block where you can set different properties. I haven't listed all of them here, but things like the minimum SDK version you want to support, things like you can give it a version name, or customize the way all the dexing is handled. And always keep in mind that it's Groovy, so instead of having a fixed string for version name, you can always add your own logic to it, and it can be as the version or the implementation of calculate your version name can be as complex as you like, right? You can read a file, which is usually what I prefer, but if in a more advanced, I don't know, environment or bigger environment, people sometimes query some URLs where they hide version information or whatever. What you can imagine with your movie knowledge, you can do it. I've seen really weird things about that. So that's basically so far so simple. So you apply a plugin, you configure the requirement things, and you have some optional things you can configure. But one big new concept in the Android build system, and the new one is build types. Build types are generally control how an app is built. So you can customize your build types to use different settings for your debug options. You can have different package suffixes. You can have different ProGuard options, and the default build type. So if you haven't declared anything, so if you have like that build script, you already have two build types defined for you. One is debug and one is release. So you can imagine for the debug build type, for example, you have all the debug options per default enabled. But for example, if you debug your code, you don't need all that ProGuard options. So that makes a process less or faster and simpler for the debug one. And if you have a release, you have hard ProGuard options. You want to have some obfuscating, whatever. You can have, or you might have different tasks you want to wire in, like, I don't know, deploy it somewhere in a specific location, or there are third-party plugins like Crashlytics where you can upload your release branch or release APK and all that kind of stuff. Or things like signing, quite popular. So I haven't mentioned it here. So in the debug, if you debug or create a debug version, you don't need to care about this signing, but you usually when you do a release, you care about signing. So you have to configure the signing process for the release. In general, how you can have custom code also for your build types. So if you have some fancy or want to have some fancy debugging options, you might need separate code for that. And the way it works is that you have a source overlay. So your production code lives in a directory called main, let's say, or source main. But if you have if you build the debug build type, there's another directory which is compiled, like it's called source debug basically, where all the sources are built and packaged into that APK. And the same is true for release or whatever. And if you have same sources in main and in build type, the build type one always wins. So it overrides the defaults of the main one. And you can have custom dependencies, which is maybe not that usual to build types, but when it comes to the next thing, product flavors, that is quite popular to have different dependencies. So you can imagine that your build types is an x-axis, like something, and the product flavors is a y-axis. So you have product flavors declare different versions of your app. So that's what I mentioned earlier. So if you have the most popular scenarios that you have a free version and you have a paid version, right, in an app world. So you can have, again, different target versions. That's quite popular, or what sometimes people do is that they have different flavors for different ranges of target versions. So maybe if you want to develop a new against a very new API of Android, you can have a product flavor that has a specific target SDK version, and you have custom dependencies which just work in that environment with that new API, whatever. But if you want to support older Android versions, you can have a second product flavor to deal with older APIs or stuff like this. And again, you have the same source code resources overlay story. So everything you define in your build flavor source directory, or product flavor, sorry, wins over the default one which is in your main source directory. And out of that combinations of build variants and build types, you would end up with, in this case with my free and paid example, you end up with 4 different build variants. A free debug one, a free release, a paid debug, and a paid release, right? That's what we call a variant. You can even drive that further if you like. So it's not that you are locked in with 2 axes. You can have a third one which uses, or there we use product flavor groups. So you can have a new axis, like if you need to support different, in that example, if you need to support different kinds of architectures, you can have a flavor group that's based on architecture. So we have free x86 debug, and you have, at the end, you have a paid RM release voice. That ends up with, if you build all that stuff, if you are on Gradle build on your command line, you end up with 8 different APKs, even more than. So flavor groups are defined that way. So we have different dimensions. In that case, I call it group 1 and group 2. And I declare product flavor and assign a dimension to it. And you can imagine if you want to have more than 2 dimensions, it gets quite complex. And what Gradle does per variant, it builds different kinds of tasks. So if you have more than, I don't know, maybe you have 3 variant product flavor groups or something, you end up with a couple of tasks we see later on. One more slide about that source code and resources overlay. So that's a default structure for an Android app. So most of your production code goes into main Java. That's quite common. Most of your test code goes into Android test. There's an addition to that. So in the latest 1.1 release of the Android build tools, they added support for unit testing, but it's completely experimental. And now what you have here is you can have named after your product flavor. You can have product flavor specific code in Java or resources in the resource folder, or you have build type specific stuff in your directory for debug, for example, for the debug build type. Let's take a look how that looks like. So I created a demo app. So what you can see here, I have a multi-project build with currently just one sub-project. It's called app. And it, yeah, that's what it looks like. And if I run, if I go into the app directory and now I want to build that app. Well, first let's take a look at the tasks. So we have just the debug build type and the release build type. But what you can already see is that there are plenty of tasks there. So you have an assemble task for building the debug version, for the release version, and you have a common one to build all of them. Different helper methods, the default ones. So you have tasks for installing it on your connected devices, and you have tasks to run your tests. So now let's run that stuff. And as you can see, there are plenty of tasks running just for building the two variants. And if I look now at the output, there are 3 APK, but the underlined one is not a final product, it's an intermediate thing. So you have app debug and app release. So now let's take a look. Yeah, and one thing just edited here for the up-to-date checks. If you haven't seen Gradle yet, Gradle knows when the task is up to date and it triggers and it marks it as up to date, which should make your build quite faster. So now let's take a look at the example app. I'm not an Android developer per se, right? So my app is quite ugly. So. Just simple one. It's called ICNDB. ICNDB is the International Chuck Norris database. I shameless took that example from Ken Kausen, who is the author of the first Gradle in Action book, I think. So basically, the idea is the ICNDB.com, I think, offers a REST interface where you can query Chuck Norris jokes. So I can, so if I click get joke, you get some statement. And all the statements here, they are only nerdy, right? So everything was about throwing exception or logging statements or whatever. So Here's a build script. Let's shut up about that. Nothing fancy so far. So we do that using Spring, Android REST template, and JSON. It's not about the implementation. But so if you look here, you already see that. So here, that's a URL configured, and it's limited to nerdy. So if you want to have adult jokes or something like this in it, we can create an app in a paid version style. So what I would like to do is to have a paid version with a different URL here, so which is not limited. And it's what I do now is I add 2 product flavors, like in the example I had before. So I have a free one with a boring nerdy jokes, and I have a paid one or pro version. So now we look here. As you can see here, in the just not working. In the Android Studio, you can select in which variant you currently want to work on. So at the moment I have free debug, which means that the source directory main is activated and I have no debug, so that's not used. But if I switch to pro version here, so now I have pro debug here enabled, and I have a resource string which is not limited. And okay, I changed the name to the SNB Pro. Can we run that? And now I can see it's not just these nerdy jokes anymore. They are not getting better. So. And if I want to build, if I run the build now with the 2 additional or 2 product flavors, I can see even more tasks get executed. And if I look into the APK directory, I can see I don't count them, 8 it should be 4, but there are some unaligned and some stuff like this, intermediate output. So that's basically variants. There are plenty of more customizations that are specific to, for example, DEX options. If you want to use incremental DEX, or you need this jumbo mode, or if you want to pre-DEX libraries to make it faster, or make it reusable for especially when you have libraries, that's important, I think. And even more customizations like AAPT options for the dealing with your assets. Yeah, that's not that fancy, I guess. So it's something that's new. There are plenty of more stuff to configure. I don't want to show everything here. So there are options to tweak your lint options, so how your code quality is checked and stuff like this. There are plenty of ProGuard options. If you're an Android developer, I guess you know more about that than me. The Java compile options are not really Android specific. It's what we ship with, so you can. So it's using the default Java compiler and the Gradle support or the Gradle options for dealing with Java compilation. Yeah, you can set target level, blah blah. Configure different compilers if you like, if you want to use the ARM compiler or the you want to fork and all that kind of stuff. More interesting, I guess, is what I wanted to show is so how to add custom tasks or how to hook into the build here. So what I did now is I run Gradle check, and per default there are linked tasks executed. So, and even in my really small program, there are already 14 issues. I'm not going to solve them, but just we can browse them. So the usually linked report is generated, and but if I'm coming from a bigger company or something, and I have common check style rules, for example, I want to use check style for my coding conventions, and I don't want to rely on linked or something which is not applicable maybe to my backend, which is based on Java, where I already use check style, stuff like this. So let's take a look on how we can add check style here. So Gradle itself ships with the check style plugin, and what we can do is we have declared the product flavors free and pro, and we have the default build types, release and debug. And what we can do now is we can iterate over the product flavors generated out of that. So we have 4, right? We have again release, free debug, pro release, pro debug. And what we can do is with that applications variants all, that gives us the container of all the variants created. So now I want to create a check style task per variant. So that's plain Ruby or Gradle syntax, sorry. So you create a task and I name it like the variant and check style, and it's of type check style, which is part of, or which is shipped as part of the Gradle distribution. I configure now the check style task. I say, okay, take that sources and exclude me some stuff I don't want to deal with, like the generated sources or the art.java file, which I don't really have influence on. And the build config file, I don't need to consider that. And to configure my check style rules, I just have a common place for that in Gradle check style XML. Yeah, that's it. And the final thing I want to do is, okay, if I run check, I want to ensure that not just the lint tasks are executed, but also the check style task. So I add a dependency, the check start task now depends on the check style task. And again, if I run that, well, first let's see if the dependency works. So you can see plenty of tasks generated. And here you have the check task, which depends on these 4 check style tasks. And if I run that, lint gets executed, still gets executed, but you also have the check style task. And it creates a XML output you expect from check style. Nothing fancy. Yeah. Sure, check style macro is fine, so I use check style instead of lint. Yeah. There are different kinds of ways how you can test your app. In general, the big benefit of the new build system is that you don't need a specific test project anymore, which was usually the case with the former build solutions. So testing is built in that in the build tool already. You can have variant-aware tests. So since you have variant-aware sources, you need to have variant-aware tests, I guess. And you can, and if you have those connected devices using that AWD manager to deal with your emulators or connected devices. So connected devices also means all these kind of Android emulators you are running on your system. And if you run your test, all those connected devices are run against, and you get a build report. Unfortunately, I fucked up my environment, so I can't show you it, and the Wi-Fi is. One thing new to Android Build Tools 1.1, which was, I think, released somewhere in March, is that they added support for unit testing. So that was a big thing missing, and now you can have simple unit test support. In the Android jar they run against, what they say is they just throw exceptions for every method you call there. And the reason they do that, or what they say is, it's just to preventing you on making false assumptions. So you should instead mock everything like you usually do in unit testing, and use popular mocking frameworks like Mockito. Yeah, I think it's just Mockito. You can, again, you have test options or test specific options. So if you want to change the default behavior, that instead of throwing exceptions, because maybe you don't want to deal with all that mocking, you can change that to say, okay, return default values instead of throwing exceptions. Yeah, there are plenty of more things to explore, especially in the Android or in the Android ecosystem. Out of that new build system, there have been already released some really nice plugins on top of the Android plugin. So my favorite ones are pretty popular Crashlytics for dealing with crash reports, stuff like this. Robo-Electrics for testing. Test Fairy is a nice one, which allows you to beta test your app. And they built quite complex plugins on top of the Android plugins already. Or Instabug for filing bug reports out of your app. They already provide default plugins, and there are all, I don't know how many Android-based Gradle plugins are already out there. We can't keep track of that. So what is currently in progress when it comes to the Android build system? So one thing they want to do in the future is add NDK support for that build tool. That will be based on the native support Gradle offers out of the box. So Gradle now builds all kind of native stuff, so C, C++. I guess Objective-C is not really necessary for Android, but we even build assembler with Gradle, or you can do that. And the idea is that the NDK support for Android will be based on this native Gradle support. One thing that is a missing feature in Gradle is, I guess in all build tools at the moment, is there is no variant-aware dependency management. So something that, when it comes to the native world, is quite common that you have variants like architecture-based things. You have x86 stuff and you have ARM stuff, and if you build native stuff, you always deal with these kinds of variants. But we are in the Java world where we have been really blessed somehow. We didn't need to deal with that, apart from different Java versions maybe. But since you're using Groovy, you might hit that point that you need to build against different Groovy versions, or in Scala it's even more popular, or that it's not popular. So what we want to have is, or in Gradle in general, is have a variant-aware dependency management. That, for example, let's take the case of an Android app. So if you build a debug version and you depend on a library. I didn't have the time to take it or show you how the libraries work, but you want to, if you build a debug version, you want to rely on a dependency which is also in the debug version, not on the release version. And currently you don't have that option. You can do, people try to do the solving with classifiers and stuff, but that doesn't really work. Well, just in a limited way. So that's something we on the Gradle side are currently working on. And the other stuff is to make it really a nice experience to build all that stuff is that we are hardly working on performance improvements. I think that's driven by two things. One is, as you can see, if I just have these two variants or these four variants, I get plenty of tasks. And in the former days, creating a task in Gradle was quite expensive. And maybe to give you a small insight, so at the moment, the way the configuration works in Gradle is that everything in the build script needs to be re-evaluated and all plugins and all that kind of stuff. So it's quite expensive to do. And we have plans to change that so that you can cache the configuration phase. So in Gradle you have this configuration and this execution phase. And for that execution phase you already have features like this up-to-date check, that tasks which are marked as up-to-date are not re-executed. But the more variants you have and the more configuration stuff you have, the configuration phase gets is really annoying you because it takes quite a lot of time. And the plan is to basically get rid of the strict distinction between configuration and execution phase and allow the configuration to be cached, reused, and all that kind of stuff we partially already have in the for task execution. And another driver, not just running those builds from the command line, but especially when you run it from the Android tools, or what is it? From that Android Studio. You need an experience which is really fast, right? If you want to type something in your build script, you want fast feedback and you don't want to re-evaluate all that kind of stuff. And so that's another driver for improving the tooling API in general in Gradle. That's really nice for us. So we got paid by Google to doing this kind of stuff to add that goodness to Gradle, but also broaden the user base basically. So we started working on the performance improvement, and I don't make any promises, but we want to have something really significant in place in the summer. We had a camp about which was just about 3 guys working 2 weeks just on performance issues or performance improvement. And the latest Gradle version, the 2.4, which is not released yet, but should be soon, shows about 20% improvement already, without all this new configuration stuff we talked about. Yeah, some links and pointers there. Obviously, this Android build team user guide. There's a Gradle user guide. There's this forum at Google for Android-specific things. Gradle.org, Gradleware.com if you need support and have money to spend. And the Android and the sample app is available at GitHub. Yeah, any questions? I guess we have no time left for questions. Okay, then thank you very much.